Hi friends, welcome to all. In this video, we are going to configure ENSA, that is Enterprise Networking, Security and Automation, Practice Packet Tracer Skills Assessment. Friends, if you like our videos, please subscribe, share and like. Also, if you wish to get any technical support, you can contact our team. All the details given in the description below. Here, they are given some instructions, so you can go through that. And also given addressing table. Coming to introduction, you are completing the configuration of the OSISC LLC network. So here we can see that network. We got this Eastern, Central, and also we are going to use OSPF area 0, and we can see all the LANs. You are not required to configure host addressing because already configured. You will practice and be assessed on the following skills: configuration of OSPF v2 routing, then customization of OSPF, then configuration of static NAT, configuration of dynamic NAT with the PAT, configuration of various types of ACLs, then configuration of a router with the NTP as a system time source, then backing up an iOS image to a TFTP server. Coming to part 1, configure OSPF. Activate OSPF. Use process ID 10 for OSPF activation on all routers. So here we can see these routers BD1, BD2, BD3 in this eastern area. And in central, we can see PP1, PP2 and PP3. So activate OSPF by configuring the interfaces, okay, of the network devices in the Eastern network where required. Here, first of all, we are going to configure in this Eastern area. And here we can see 3 routers, BD-1, BD-2 and BD-3. And here we are going to activate OSPF by configuring the interface. So we will do that first. Coming to BD1. Enable configure terminal. So we will enable OSPF, router OSPF, process ID specified as 10. Then we will go to the interfaces. Here we can see in BD1, we got 3 connections, 3 interfaces, but no need to configure towards ISP. So we will configure OSPF only to this central and to this LAN. So here we can see 2 interfaces. We can verify that using do show interface IP interface brief. So here we can see those interfaces used here. We can see G000, and also here we can see serial 0/1/0. So this is going towards ISP. Even we can verify from here, serial 0/1/1, correct. And also they set public IP here for this interface, serial 0/1/1, which is connecting to the ISP, right? So we will go to the interface. G0/0/0 IP OSPF 10 area 0. Then we will go to interface serial 0/1/0 IP OSPF 10 area 0. Next we will do it on BD-2. Here also we can see 2 interfaces connected. That is G0/0/1 and G0/0/0. enable configure terminal. Here I will give this a show command, do show IP interface brief. So it's a do show IP interface brief. And here we can see those two interfaces. We will go to interface G0/0/0 and we will give a IP OSPF 10 area 0. Then we will go to interface G0/0/1 IP OSPF 10 area 0. Also we can activate OSPF for router OSPF process ID 10. Now we will go to BD-3, enable configure terminal, router OSPF 10, do show IP interface brief. So here we can see the interfaces G0/0/0 and 0/0/1. So first we will go to G0/0/0 IP OSPF 10 area 0. Then we will go to interface G0/0/1 IP OSPF 10 area 0. Here we activated OSPF by configuring interfaces on these three routers in this eastern area. Next is activate OSPF using network statements. Yes, previously we were using this configuring the interfaces and we activated OSPF. Now we are going to activate OSPF using network statements and inverse masks on the routers in the central network. So here in the central network also we can see three routers. Note, for the purposes of this assessment, please enter the network statements in the following order. So they given here for PP1 router, we must give first serial 0/1/1, then a serial 0/2/0 network, then serial 0/1/0 network. Okay, this is for a scoring purpose and we will give in this order only. And they given for other routers also for a PP-2 and PP-3. So make sure that we follow this order. We will do it one by one. So first of all, we will do it on this PP-1. So here we can see in central, we have this router. Okay, enable configure terminal, router OSPF 10. Okay, now we will give do show IP interface brief. So we should see the order they given serial 0/1/1, 0/2/0 and serial 0/1/0. So according to this, we will set the network. Network first one is serial 0/1/1. Here we can see that. Just I will copy this, or even we can use one more show command, do show IP route connected. So it will be more easy. Now we can give a network. Here is serial 0/1/1. So we get the network address here. Very easily we can copy from here. Then we need to give the wildcard mask /30 0.0.0.3 area 0. Next one is a serial 0/2/0 network. We can copy it. Then wildcard mask, then area. Third one is serial 0/1/0. Here is the network address. Yes, let me copy that. Then wildcard mask and the area. Now we will go to PP-2. Enable configure terminal. We will give router OSPF 10. Okay, we will verify the interfaces and its network address. We will give do show IP. We will give show IP route connected. Okay, so we will give first serial 0/1/1. So we'll copy this network address. Network, then wildcard mask, prefix given /30, 0.0.0.3, area 0. Then next one is network. Okay, just to press tab button when you get this loading to full. Serial 0/1/0. It's a 244. Okay. Then remaining commands. Then third one is G000. We will get the network address. And here we can see the prefix they given /28. That means 240. Wildcard mask will be 0.0.0.15, area 0. Next we will go to PP-3 for interfaces. Enable configure terminal. Router OSPF process ID 10. We will give a do show command, do show IP route connected. We can see those 4 interfaces and its network address, prefix. Okay. So network, first we will give serial 0/1/0. Let me copy the network address. /30. So wildcard mask is 0.0.0.3, area 0. Next is serial 011. Okay, we'll copy that here. Press tab button. Okay. Space. Next is G000. Prefix is /24. Network. Sorry, I have to copy that network address for a G000. Here it is. Then wildcard mask 0.0.0.255, area 0. Then the last network G001. Here is that. /24. So same like previous one. In step 2, configure router IDs. Configure router IDs on the multi-access network routers as follows. That means here in this Eastern BD1, BD2 and BD3. So we will configure this router ID. So first of all, we will go to BD1. Enable configure terminal, router OSPF 10, and we will set the router ID 9.9.9.9. Okay, so it's a router ID. Perfect. Then we will go to BD2. router OSPF 10, router ID 8.8.8.8, then BD-3, router OSPF 10, router ID 7.7.7.7. Coming to step 3, customize OSPF operation. Configure router BD1 with the highest OSPF interface priority so that it will always be the designated router of the multi-access network. So here we can see that multi-access network, and we are going to set the highest priority for this BD-1. Here in this multi-access network, we can see we should go to this interface, that is G0/0/0, and we will set the priority. Exit, and we will go to interface G0/0/0, IP OSPF priority 255. On router BD1, again, configure a default route to the ISP cloud using the exit interface command argument. So we are going to configure the default route towards ISP cloud. And here the exit interface is serial 0/1/1. So we will configure that. Exit, and we will set IP route 0.0.0.0 space 0.0.0.0 space. So we have seen the exit interface, that is serial 0/1/1. Okay. Automatically distribute the default route to all routers in the network, because already we configured the gateway of last resort here in this router BD1. So we are going to distribute using the command default information originate. So we will go to router OSPF 10, default information originate. Configure the hello and dead timer values on the interfaces that connect to BD-1 and PP-1 to be twice the default values. That means here we can see BD1 interface is serial 0/1/0, and connecting to central PP1 interface is serial 0/2/0. So here we are going to change this hello and dead interval timer. So we need to configure twice the default values. So we can verify the default values, right? Let me end show IP OSPF interface. So this interface is serial 0/1/0, serial 0/1/0. And here we can see hello is 10 and dead is 40. Here we will configure hello interval as a 20 and dead interval as 80. Okay, we can do that. Configure a terminal. We will go to interface serial 0/1/0, IP OSPF hello interval. We will give it twice. Default is 10, so it's 20 now. IP OSPF dead interval 80. On the other side, enable configure terminal. We will go to interface serial 0/2/0, then IP OSPF hello interval 20. It should be same on both sides. Then IP OSPF dead interval 80, 4 times of hello interval. Next is configure the OSPF routers so that the default cost value for all gigabit Ethernet interfaces will be 10 and the cost value for fast Ethernet will be 100. Okay, so we need to configure on all the routers. We will start from BD-1. Exit router OSPF 10 and we will set this auto cost reference bandwidth. So here I am not using any shortcut, I am typing the entire command. So we will give it 10,000. Okay, just I will copy this command because we need to give the same command in all other routers. Next we will go to BD-2. Okay, we are already in router mode. So just I will paste it and press enter. Coming to BD-3. Okay, already we are in a router mode. Same command on all the routers. Coming to PP-1. Here we are on interface mode. We will go to router mode. Router OSPF 10. Then we will give that auto cost reference bandwidth. Next we will go to PP-2. Enable configure terminal router OSPF 10 auto cost. And coming to the last router PP-3. Enable configure terminal router OSPF 10, right? Router OSPF 10. Then here is our auto cost, right? So we done on all 6 routers. Next is configure the OSPF cost value of PP-1 interface serial 0/1/1 to 50. So here we can see that interface on a PP1 serial 011. So we will do that here. We will go to that interface that is serial 0/1/1 IP OSPF. So we are going to set the cost as specified, that is 50. Next is configure OSPF so that routing updates are not sent into networks where OSPF updates are not required. Okay, we will do it on all the routers wherever applicable. First of all, we will do it on BD-1 and in order to send the update towards ISP cloud. So we can set this interface serial 0/1/1 as passive interface. So already we are in router mode. Okay. So passive interface serial 0/1/1. Next we will go to BD-2 and here we can see this LAN. No need to send the update towards this switch. So here the interface is G0/0/0 and also on BD-3 G0/0/0. So we will configure as passive interface. We can go to interface G0/. Before that, we are already in router mode. We will give a passive interface passive interface G0/0/0. Perfect. Now we'll go to BD-3. We are in a router mode. Passive dash interface G0/0/0. Now coming to central, in this router PP1, there is no passive interface because all the interfaces are connecting to routers. So update should be sent. Coming to PP-2, here we can see LAN 3 interface is a G0/0/0, which is connecting to the switch. So no need to send the update. Also in the other router PP-3, we got two LANs, LAN 4 and LAN 5. We can see those interfaces G0/0/0 and G0/0/1. First of all, we will configure on PP-2. Already we are in router mode, hence we will set the passive interface G0/0/0. Then coming to PP-3, here we have two passive interfaces. Okay, we are in router mode. Passive interface G0/0/0 and also passive interface G0/0/1. Next, we will go to part 2, configure NAT, network address translation. In this part of the practice skill assessment, we will configure static and dynamic NAT at the network edge. That means on this BD-1. So configure static NAT. Configure static NAT to translate the address of the internal server on LAN 1 to the public address of 192.0.2.115. Verify that the translations are occurring. We will configure on this BD-1, this static NAT. We should get the IP address of our internal server, and here they given the public address already, so it is easy to configure. Let me open this internal server. Use services tab is locked. Okay. Desktop IP configuration, and here is the IPv4 address for this internal server 192.168.11.100. So we will use this to configure the static NAT on BD-1. So we'll configure it. Exit in the global configuration mode. IP NAT inside source static. We are going to configure static NAT, and now we need to give the IP address of our internal server, that is 192.168.11.100. Then we need to specify our public address given here. I will put a question mark, and we can see inside global IP address they already specified to give 192.0.2.115. Then we need to specify the NAT inside and outside. So here we can see the interface serial 0/1/1. This is IP NAT outside, and this is this interface G000 IP NAT inside. We need to configure it. So we will go to those interface. First, we will go to serial 0/1/1, and we will give IP NAT outside. Then we will go to interface G0/0/0, and we will give IP NAT inside. Next, in step 2, configure dynamic path port address translation. So we need to create the access list 1 to allow all addresses in the 192.168.0.0/60 network to be translated. So we will create this access list in BD-1 in the global configuration mode. Exit, and here let me create access list 1, and we are going to permit 192.168.0.0. Then we should specify the wildcard mask 0.0.255.255. Create a NAT pool named pool-1. It should use address in the range. So 192.0.2.116 till 118. So we will create this pool in this BD-1. IP NAT pool-1. So here we should give in a capital letter because for the scoring purpose. Okay. And the address given, okay, 192.0.2.116 till 118. So just I will copy this. 192.0.2.118. Then we must specify the net to mask, that is 255.255.248. Configure NAT to dynamically use the addresses in the pool for all traffic entering and exiting the company network. Remember that it is likely that more than 3 hosts will be accessing traffic on the internet because we configured 116, 117 and 118. We will do that here. BD-1 IP NAT inside source list. We already created the list 1 and pool name is pool-1, and here we are going to give a overload because we are going to configure PAT. Now we need to specify IP NAT inside and outside. We already given for this outside IP NAT outside on serial 0/1/1 and also for this interface G0/0/0. Now we will specify for this interface serial 010. We need to go to that interface serial 0/1/0, then IP NAT inside. We will go to part 3, configure ACLs. Configure access control list to meet the following requirements. They given a note, use host and any keywords whenever possible. Always explicitly configure the default deny condition when it is to be used as part of the ACL functionality so that it can be logged when the condition is met. You do not need to specify the default deny condition if it is contracted with permit IP any for this assessment. All ACLs should be placed in the most efficient location possible according to the guidelines specified in the curriculum. Create a named standard access list to explicitly prevent all external traffic accessing the telnet lines on BD-1 router. So name the list VTY-block. Okay, so we need to create a named access list. All addresses on the 192.168.0.0/16 network only should be allowed to access the VTV lines. Verify that the list works as specified. We will create this VTY-block access list in this router BD1. So IP access list standard name is VTY-block. Okay, now we will permit only 192.168.0.0 network with the wildcard mask 0.0.255.255. Then deny any other than 192.168.0.0. We will deny everyone. Now we will go to line VTY 0 to 15 access class VTY-block. This is what we created our standard ACL in inbound direction. Next is create a numbered standard ACL to prevent all hosts on LAN 1 from accessing LAN 2. Use a 10 as the number for the list. So here we can see LAN 1 from accessing LAN 2. So here we can see our LAN 1 and here is our LAN 2. We will create access list near to LAN 2, that is on BD-3. Enable configure terminal. So we will create the access list. We will give a 10 because they already specified here to create a 10. Deny, we are going to deny this network 192.168.11.0. 192.168.11.0. Then we will specify the wildcard mask 0.0.0.0.255. Access list 10 permit any. So we will deny only this network to access this LAN 2, and we must permit all other networks. So access list 10 permit any. Now we will apply this ACL. So here we can see the interface G0/0/1. So if any packets come from LAN 1 to this network, it should be denied, right? So here we can give for this interface G0/0/1. Interface G0/0/1, and we can give a IP access group access list is 10 in. Next is create an extended numbered ACL that will prevent traffic from the LAN 4. So here we can see LAN 4, a network from accessing the HTTP service that is running on admin server. So here is our admin server in LAN 3. All other traffic from LAN 4 host should be able to access the network. Number the list 101. Okay, we can create that. We will create the extended numbered access list near to the source side. We will create on a PP-3. Enable configure terminal. We will create access list 101. We will deny TCP any host is we should get the IP address of our admin server 192.168.33.14. Just I will copy this and paste here, equals our www. Next we'll give access list 101 permit IP any. So here we deny only this www. Now we'll go to the interface G000 here, and we will apply that. ACL we created interface G0/0/0 IP access group 101 in. So here any device from this LAN 4 will not be able to access this admin server. That is a HTTP service. Yes. So now coming to part 4, manage network devices. In step 1, we will configure NTP, that is network time protocol. Configure a router PP-2 to use admin server as its time source. So here we can see our PP-2. Enable configure terminal. And in global configuration mode, we will set NTP server IP address. I think it's already copied. Yes, 192.168.33.14, the IP address of this admin server. So he will act as our INTP server. Coming to the last step, backup iOS 2 server. Backup the iOS image file on router pp-2 to admin server. Okay, we can do that. So we should see the iOS file name. Exit. So let me check the file name. I will give show flash, and here we can see our file name ISR 4300 universal. So we need this entire file name including .bin extension, so that we can copy from its flash, I mean this iOS to our TFTP server. Just we can copy from flash because this iOS is in the flash to TFTP. So what is the file name, source file name? So just I will copy this file name including bin extension and paste here. Okay, now what is the name or the address of remote host? So we are going to save it in the TFTP server. Here it is admin server. So its IP address is 192.168.33.14. And what is the destination file name? So we will save it in the default file name here. They shown. Just press enter. Yes, it is copying. It may take some time to copy, and once it completes, you can see your percentage will be increased. Still it is copying, and here we can see that process. Yes, so here we can see our iOS image is copied from our router to TFTP server. Here we can see our completion status 100%. So that's all in this video, that is configuring ENSA practice PT skill assessment. Now friends, if you get any doubt, you can contact our team. All the details given in the description below. Stay connected. We will meet again with the next video. Thank you.